Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, welcome to Mammoth Interactive's course on making a ninja game in Unity 3D. My name is Glaucopedis. I've been making games since 2010, and throughout the years I've learned how to work with different technologies like Unity, Unreal, HTML5. I've also learned other tools like Construct, and I'm going to share this experience with you by making this course in the simplest and nicest way possible. So we are going to learn how to make a few different ninja mechanics in this game, and then wrap up the game and get it ready to be played. The first step on making this game is to set up a new project in Unity. So if you don't have Unity yet, you can download that on unity3d.com, or if you have, you can just open Unity and press the new button on the top right to make a new project. Every game is going to be in a different project, so we need to set that up. The project name is simply going to be Ninja. We're going to keep things simple. And the location of the project is going to be my home folder / projects. I use this folder for storing all of my Unity and any other technologies that I use. And why is that? Some beginners use the documents or the downloads folder, but that's not very recommended. Okay, you're going to mix your files, your project, with things that are unrelated to work, and that might not be a good idea in the long haul. Things might get a bit messy through time. So we just make a projects folder, and with that in mind, we should be good to go. Okay, so Ninja, projects folder, we're going to use 3D mode. Even though this game is going to have a little of a two-dimensional feel, we're going to want it to be 3D under the hood, so we need to make sure this is active. And after we're done with this, we just press create project and wait for Unity to do its job. It's simply going to start the project, okay, generate all the necessary files, and then get us ready to start. So once we open this window, before we actually implement anything, we want to go to the assets folder. Okay, this is going to store all the necessary files for your project. And to make sure that things are going to be organized, we can already make some of the folders that are going to be necessary. And the first one, which is the most basic, is you go to right click, select create, then folder, and this is going to be project. Why do we do this? Okay, if we are in the assets folder, we are working with our project, but so why do we need to make another project folder? We do this because if you import any other asset package from the Unity Asset Store or one of the built-in packages that you already have in Unity, like 2D, cameras, characters, effects, environment, there are tons of different options here. So when you import these packages, they're going to be folders here in the assets folder, in the root of the project, that are not directly related to your project. They come from other places, other projects. So it's interesting to make that a little difference among everything you do. Okay, and in the project folder, we're going to make just a few folders. Okay, let's create a folder that is going to be scripts. We're going to put all our code here. We're also going to have scenes. Actually, let me delete this. We're going to have a scenes folder. So we right click, choose create, then folder, scenes. Then again, we create another folder, and we're going to type materials, because while we don't have the final art, we're going to make some materials here, and this should be enough for us to get started. Okay, so to make sure that we're going to have a scene to work on, we're going to hit file, then save scene. We're going to name this scene as game. Okay, it's going to be here in the assets folder, and we're going to drag the scene to the scenes folder. Okay, so we just started just a few minutes, and we already have a simple yet effective and nice hierarchy here. So let's move on to the next lesson. The most important element in this ninja game is the player, the ninja, the one that we're going to control to avoid enemies and destroy some of the enemies, and well, just to survive as long as we possibly can. So let's make a very simple scene here. First of all, we want to make a floor for the player to stand on. So we're coming here in the hierarchy window in the game. We're going to right click, choose 3D object, and then we're going to choose cube. Okay, we're going to have a nice little cube here in the scene. Since we want to make this a floor, we're going to change its size. So we have to deal with this cube's scale. So I'm going to change x to 20, y to something very thin like 0.1, and z as 20. Okay, so we have a white floor. And we also change its position to be 0, 0, 0. So it's going to be in the middle of the world. Okay, this is exactly where we want it to be. Now, the other thing that we want to adjust for this is we want to give it a material. If we use this white color, it might be very hurtful to the eyes and, well, to be honest, very difficult to see things in here. So we're going to the materials folder we just created. We're going to right click, choose create, then we're going to choose material, and I'm going to name this simply floor. With that material here, if you look at the inspector, you have details about it. So we're going to change its color. And if you want to change the color changing in real time, we can drag this material and drop here in the floor in the scene window. Apparently nothing changed. But now if you go to the color picker and change to another color, well, it's going to update for us. So let's choose a tone of color like this one, like a sandy color. And we might want to adjust the smoothness of this floor, okay, because it might be too shiny. That's not what we want, so let's make it almost like it's not shiny. Okay, I think 0.5 is going to be a good value, okay, or maybe even less, so 0.2 might be better. Okay, so very simple, a very simple element. And now that we have this floor, we want to make our player. So to make the player, we're going to do something very similar, but the order that we're going to do things is going to be a bit different. When we are making a game in the beginning, we want to make sure that things are easy to change. Okay, this is part of prototyping. You start by coding, then you drag the final art and you just drop the art here in Unity. And to keep things simple, we're going to right click in the hierarchy and just choose create empty. We made an empty game object. Just as a heads up, we're going to add a cube. Okay, our ninja is going to be a very simple cube. But while we don't do that, okay, while it's not turned into a cube, then we do a simple game object. I'm going to put it in the position 0, 1, 0. Okay, so it's going to be more or less in the center of the game. And inside the game object, I am going to right click, choose 3D object, and then cube. So why I do this? We do this because when we want to change the model for our ninja, we're going to simply replace this cube. So for example, hey, the ninja is now going to be a sphere. So I can just remove the cube, and inside this game object, I can add a sphere. So it changed its shape. Okay, so that's pretty much why we're doing these things. Now, I want you to select the cube, and we want to look at the inspector and remove this box collider because the cube itself, the mesh itself, is not going to be responsible for processing the collisions. So we're going to click here and choose remove component. And you're going to see that the cube no longer has that green outline. But we're going to the original game object, we're going to press add component, and we're going to add a box collider. Okay, so it's going to be still taking the same size as the cube, but we can change that to other sizes if we want later. Okay, so it can take more space or less space. Now with the game object selected, I'm going to name this player. It could be ninja, but to keep things consistent with other projects, let's just name this player, because of course it's the player. And another tip for you is, we can right click on the player, choose create empty, and we're going to rename this game object as container. Okay, or you might want to change that to model, whatever name you feel it's better. And we do this because later when we import the model in here, it's going to be easier for us to perform some rotations and some other adjustments to the model. So with this in mind, we're going to grab the cube and drop it inside the model. Okay, so right now there is not much difference between making a player or simply making a cube. Okay, we made three different elements inside the player, but be sure all of these things matter. They're going to make your work much easier than it would be. Okay, so now we have a very simple player model. It's right here. Okay, well, it's a very simple white cube, so we should add a color to it. I'm going to right click on the project, select create, and then I'm going to choose material. This is going to be player, and now we're going to choose another color for this player. So let's change, select a tone of blue, between blue and green, so it's going to contrast well with this floor. And I'm going to drag this material to the player. So this is how the player is going to look like. right? And to make the player to work, we have to write specific logic to it. We have box colliders, we have meshes, we set positions, but there's nothing specifically for controlling how the player works. So we're going to the scripts folder, and here we right click, choose create, and then C# script. And this is, of course, is going to be simply named player. After we do this, let's wait for the compilation to be finished, so the spinning wheel disappears, and now we're going to drag the player script in here. Okay, and if you double click that script, Mono is going to open, and it's going to show you the file that we're going to edit to make sure the player is going to behave. Okay, so we're going to apply movement to the player and, well, make everything work, right? So let's work on this movement in the next video. With the game scene the way it's been developed, if we simply save it, okay, by going to File and press Save Scene, and if we press the play button, you notice that the player is going to be hovering over the floor. Okay, it's not going to fall. Well, it's looking like this. Okay, there's no gravity being applied, but we're going to need this as we develop the game, both for the player and for the enemies that we're going to build. So to adjust this, we need to select the player game object in the hierarchy. And we're going to look at the inspector, because there's this important button here called Add Component. We're going to click on it, we're going to search for rigid body, and we're going to click on it again in the rigid body component, so it's going to be added. And you're going to see that you're going to have different fields here like mass, drag, angular drag, gravity. So, well, the physics are going to be applied now. And this time, if you press play, the player is going to fall. Okay, and this is great. This is something that we wanted. But there is something that we have to make sure is not going to happen. If we move the player to the sides, then there might occur that it's going to flip, okay, that it's going to rotate to some other directions. But this game is going to be very simple, okay? Even though it's 3D looking, it's going to have the two-dimensional spirit, okay, that arcade spirit of simple games and still addictive and very fun. So we're going to the rigid body component, we're going to click on constraints, and we're going to make sure that we want to freeze the rotation of this element. So we're going to freeze X, Y, and Z. So we make sure rotation doesn't happen. Okay, so this is the player. Okay, we have the script, we have the box collider for processing collisions, and we have the rigid body. But how do we make the player move? There are several ways to do this, and there are going to be several ways to make the player to perform movement. But in this game, and in other alternatives, in other variations of the game that we're going to build, the player is going to move based on whatever we are clicking in the window. Okay, this is going to be decisive to make the player moving properly. So if we click on the left side and we drag to the left, then the player is going to be moving to the left. Okay, so it might seem a bit complicated at first to make this logic, but it's actually not that complicated. Okay, so first of all, in the player, we're going to need a variable that is going to define what was the place that we clicked first. Okay, so here we need to type private vector2 and then click origin. Okay, so how does this happen? When we click in the screen, we're going to return coordinates based in the screen space, not in the world space. Okay, so for instance, normally you should be watching this in a mobile phone or a device that contains a resolution of 1280 pixels by 760, for example, just shooting out some numbers. So there's a two-dimensional space here. You have a certain amount of pixels horizontally and a certain amount of pixels vertically. When the player clicks in the window, then we need to make sure that we are going to track where the player clicked or touched the screen. Okay, it works on computers and on mobile phones. And as you move your pointer or your finger, we're going to compare what was the distance that your finger or your mouse pointer traveled. And with that in mind, we're going to communicate that to the player, what has been the delta, and the player is going to move to that direction, okay, to where we are dragging our finger to. So this is going to be the important logic here. And we want to have that click origin variable here. And in the start method, we want to set that click origin to be simply 0. So you can type click origin equals to vector2.0. And now, how do we get where we are clicking? Okay, how do we get the coordinates of where we are clicking? Here in the update method, we're going to make a very simple test. We're going to type debug.log So we're going to print message to our console, and between parentheses we're going to call the class input, then mouse position. Okay, so as you see in the summary, it says the current mouse position and pixel coordinates. So we're going to print input.mouse position. Okay, so let's save this. Let's go to Unity. We're going to wait for the compilation to complete. And after this is done, we're going to go to the console window. You can ignore this warning for now. We're not using the click origin just yet, but that's okay. And if we press play, you're going to see that you can get where the mouse is. Okay, so this point here is the coordinate 0 on X. Okay, and if you move up or down, it's 0 on Y as well. Okay, so here is pretty much the beginning of this vertical, of this two-dimensional space, and here is the end. And here is a catch that lots of beginners do. There's a problem with this. Okay, if you get the distance just by using these pixels, okay, just using this as 0 for X and this as 445 for the right limit of the screen, and you simply use the distance using these units, you're going to have a big problem, okay? Because devices with a lower resolution rate are going to behave very, very, very differently than devices with a high resolution. So, for instance, a 4K mobile phone, for example, would make the player move much faster than a very simple phone that has a resolution of 600 by 400 pixels, for example. So instead of using these values directly, instead of simply getting the coordinate of where we are hovering our mouse, we should get the percentage of the screen where the mouse is or where your finger is. This is very important, and it saves you a lot of trouble. Okay, so what we want to do is, instead of simply getting the position, we want to know what is the percentage of the screen where we are touching. So to test this here in this update method, here's what I'm going to do. I'm going to put this string x, then a comma, and that space plus input.mouseposition.x. Okay, I'm going to print the position in the x-axis. Now we can copy and paste this line and do the same thing for y. So y here and y here. And here's what we're going to do. We're going to enclose both of these input calls between parentheses, okay, like this. And in the x part, we're going to divide by screen.width, okay? And here we divide by screen.height, okay? So if x is the minimum value possible, which is 0, this is going to return 0. Okay. If it's half the screen, this is going to return 0.5. If that's the complete of, if you're in the complete limit of the screen to the right, then this is going to return 1. And these percentage values are great. Okay, it's going to simply vary between 0 and 1, and that's independent of the screen size. Same applies for y. If you're touching the bottom of the screen, it's going to return 0. If you're touching the top of the screen, it's going to return 1. So this time, if we save and we go to Unity and wait for this to compile, we're going to press the play button. Okay, so here we are, and we're getting the values of x and y. Okay, as you see, if we move to this part of the screen, okay, almost, I can't move precisely there, but you're going to see that x and y are very close to 0, and if we move here, they are very close to 1. Okay, if we put the pointer in the exact places. Okay, just check the console to see the values that are being printed. Okay, so with that in mind, we can already work on a logic to see how much our pointer has traveled in the screen, and we should be able to also tell what has been the delta of the movement, so the variation of the movement. To be able to tell what has been the movement percentage, we need to make a few adjustments here. First of all, let's tidy up the update method. We want to get the percentage of the pointer in the screen. So let's make a nice variable to store this. So we're going to type vector2 screen coordinates, or better than this, we should type viewport coordinates. This is going to be a new vector2. So we need to type the value for x and for y. We can simply copy what we did here in the simple division and paste here as the first parameter, and the second parameter is going to be the value for y, okay, the vertical value. So I'm going to cut this from here and paste it here. Okay, so we are storing the coordinates here in the viewport coordinates. They're going to vary between 0 and 1. Now that we do this, we need to define the movement, okay, the variation of where we are clicking. So in the update method, we need to check if the mouse is clicking. So we're going to type here if input.getMouseButton. Okay, so this is going to is a variable that receives a button as a parameter. In our case, we can simply use 0, okay, for the left mouse click or the touch in a screen. It works both ways. And this is going to return true every time the mouse is being held down. Okay, so every frame it's being held down, this is going to happen. Okay, so here we are clicking or touching the screen. Let's add a comment. Clicking or touching logic. And what we do now is we need to check if click origin equals to 0, because if that does, it means we've just started touching. Okay, so we ask if click origin equals, so two equal signs, to vector2.0, then we're going to do something here. Okay, let's not worry about this right now. Actually, okay, we can start that. If click origin is 0 and we are touching, we're going to change the click origin to be viewport coordinates. Okay, so that means that this is going to be our reference now for where we started clicking. This is going to be our origin, and we're going to add here an else. Okay, so if it's different than 0, then that means we're going to calculate the variation that we did. Okay, so what we're going to do here is type vector2 variation equals to click origin, or better than this, viewport coordinates minus click origin. This is going to store the variation, and we can print that for you to see. So I'm going to type debug.log, then variation. This is going to print this vector. Okay, and another important thing, if we release the mouse, click origin needs to go back to vector2.0. So we need to add an else here. I'm going to add else, and then I'm simply going to add click origin equals to vector2.0. Okay, so we can already test this. We can test this debug log call here. So if we save this and we go to Unity, we wait for the compilation to be finished. Now I'm going to press play. Okay, the player is here. Notice that nothing is being printed in the console. If I click and I don't move the mouse, it's going to say 0, 0, because the variation is basically none. But if I move to another side, notice that the values, they start to increase. Since I'm moving only to the right, I see the variance only in the x value. Okay, pay attention to this. X is the first one and y is the second one, horizontal and vertical. Okay, so let's start again. If I click here in this position, let me remove this collapse option because it might be difficult for us to see. So if we start clicking, it's going to be on 0. If I move up, we just see a variance in the vertical value. If I move down, same thing. And if we move to different sides, we're going to see the variation on all axes. And this is very important. Okay, this is a very consistent mathematical logic that we are making in order to make the player to move. Okay, and now that we have these things, well, we should be ready to make the player perform its actual movement. Alright, so now that we have the variation, we should be able to make the player to move depending on where we are clicking. So what we're going to do is, just like we have the click origin, we should make some sort of movement origin for the player, or the player's original position. So I'm going to make here a private vector3, then original position. Okay, so we're going to save this, and whenever we click, okay, whenever we start the player's movement, which is taking place here, I'm also going to add a original position equals to. So I need to get the original position of the player, which is transform.position. Okay, this is going to be our anchor where the movement starts. Okay, the original position. And now when we are here, which means we are moving, the player should change its position. Okay, so what we have to do here is we're going to type transform.position equals to a new vector3. So we're going to build the player's new position. We have to set the values on x, we have to set the value on y, and on z as well. But the catch here is we're not going to make any special movement in the y-axis. Okay, and why is that? If the player is jumping for some reason, we don't want to change its vertical position. We want gravity to be untouched. We just deal with x and z. Okay, so on y, I'm simply going to copy whatever position we have. So that's transform.position.y. As for x, we're going to start with the original position .x. But then, if we did it like this, the player will not move at all. So we have to add an increment, okay? And here is where things are going to look interesting. Here, we're going to get variation .x, okay? So we're going to get the value that the player moved, and we do the same thing on z. So original position .z plus variation dot, and instead of using z, because variation contains only two axes, x and y, we use y. Okay, remember, we are making a mix between a 3D game and a 2D game. Our player is only going to move in the x and in the z axis in this specific game. So if we use x, okay, the player is going to move horizontally, but if we use y, so if we move the mouse up or down, or we touch up or down, we change the depth of the player. That's why we do this, z here and y here. Okay, let's save this and let's give this a try. I'm going to Unity. Let's wait for this compilation to be finished. Let's also stop this scene. And now I'm going to press play. Okay, so if I click here and move to the left, notice that the player is moving, which is fantastic. Okay, it's very simple. I just click and I move, and it's going to move the same way. Okay, and if you were on a bigger screen like that, okay, if you maximize the screen by clicking on this drop down menu and pressing maximize, it's going to behave in percentage. That's why we did that logic. Okay, doesn't matter if we are in a big screen or a small screen, screens with small resolutions, it's still going to work okay, in the same proportion. But as you might have noticed, it's a bit difficult to control our player. Okay, well, it's very hard to move. Okay, we have to click several times in order for the player to move to the other side, and this is where we're going to improve our player a little bit. We're going to add a public variable here that is going to define the player's speed. So now I'm going to type public float horizontal speed. Okay, and let's default that as 10f. Okay, we might change this, and we're going to use this horizontal speed here where we use the variations. So we're going to type variation.x multiplied by horizontal speed. Same thing for z, multiplied by horizontal speed. So I'm going to save this. I'm going to Unity, wait for the compilation to be finished, and if that's too much, we can at any time change that speed. Okay, so we press play. We have our player here, and now it's looking like this. Okay, the player can move closer to us, can move further away from us, and we can move much easier from the left to the right. Okay, and there are a few things we have to do. Okay, in a few games the player is going to be able to move in the depth axis, but in some the player won't be able to, and it's the case of this game. Okay, so let's not use the z-axis. And how do we change this? Okay, we can make another variable here that is going to be a public bool. Then we're going to actually, instead of bool, let's type vector3, and then we're going to type here something like axis available, something like that, or just bool lock z. Okay, that works just fine. We can start with as false by default. Okay, it's going to lock the movement in the depth axis. And here, where we set the position in z, we should actually ask a question, because if lock z is true, then we want to repeat the position in where it was. So we're going to type lock z, and we add a question mark. Okay, if lock z is true, then we're going to type transform.position.z. Okay, let me do this. Okay, if lock z is true, transform.position.z. Then we add a colon, because if lock z is false, that means we are going to move in the z-axis. So that's a ternary operator. Okay, we're simply asking question. If that is true, we return this first value. If that is false, we return this second value. We can save this, go to Unity, and give this a try. Okay, so with the player here, we can press the play button. Okay, and if we move the mouse up and down, it's going to move closer or further away from the camera. If we press lock Z, up and down no longer moves the player. Okay, as you can see, it's completely locked, only the horizontal movement. I think we might want to change that horizontal speed a little bit. So to 15, yes, 15 is going to be interesting. So let's stop this and set it to 15. Okay, so the movement is working very well here. Okay, we can quickly move the player to other positions, but the movement right now is instant. Okay, the player is moving straight to the position that we defined. So how do we smooth that movement to give a more professional, a nicer look to the player? To work on this, we can make another variable here that is going to be private vector3 target position. Okay, so this is going to be our the position where the player is going to be. Okay, and we do this because instead of straight setting the position here like we're doing, transform.position equals to new vector3, we're going to type target position equals to new vector3. Okay, so that's good, that's going to work, but how do we make the player to move? Here in the bottom of the update method, okay, before the clicking or touching logic, we're going to add a new comment, which is going to be movement logic. And now we're simply going to type transform.position equals to vector3.lerp. Okay, this method is going to make a linear interpolation between two vectors, and that means it's going to basically smoothly change a vector3 from one to the other at a certain speed, at a certain rate. The first parameter is the original position, which is transform.position. The second one is the target vector, so we simply type target position. And the third value is going to be the time component, so how quickly that interpolation is going to happen. I'm simply going to type time.delta time, okay, for you to check this out. Okay, so now let's save that, let's go to Unity and see how that smoothness is going to work. Okay, so I'm going to press play. Liberty of false. If I move here, notice that it takes some time for it to reach the target position. Okay, so that's some sort of movement smoothness. Okay, it really depends on how quickly you move from one place to the other. So that's something that we want to change. Okay, so a few things first. That name horizontal speed should be changed to something like movement amplitude. Okay, this is going to be the factor that we're going to use to multiply the movement based on the variation of the click that we did. So we're going to copy that amplitude and paste it here. Okay, and now we can make a global speed variable, public float speed, and let's use maybe 8 as the full here. Type 8f, and here we do the movement logic. We're going to type transform.position, target position, time.delta time, and now we type multiplied by speed. Okay, multiplied by speed. So you can save that, go to Unity, and give this a try. Okay, apparently horizontal speed is still used, so you can just double click. There we go. This is going to be movement amplitude as well. Okay, so in case you face any errors, just double click and it's going to take you straight to the line that is giving you a problem. Okay, now we press play, and if we move to this position, it's going to be here. If we move it like this, it's going to be here. Okay, so we have some smoothness going on here for us. Okay, so it's going to work just fine. Okay, and you might have noticed that when the player fell, there was some stuttering, okay, until it reached its target position before, well, it stabilized. So you can actually fix this, okay, you can actually adjust this. If you see the signature of vector3.lerp, okay, it's going to return another vector, okay. So what we can do here is type vector3 smooth position, okay, or yeah, smooth position is going to be that lerp that we did. Okay, so it's going to look like this. And now the transform position is going to be a new vector3 that is going to be smooth position.x, then transform.position.y, and finally smooth position.z. So it's more or less the same logic that we did before. We're not going to mess with the vertical position, just x and z. Okay, once we finish this, we can give this another try. So we press the play button, then the player is going to fall to the X and Z position and it's going to move. Okay, if we lock Z, we only move in the horizontal axis. Okay, so let's stop this, mark lock Z, we're going to save our scene, and then we have the full player movement. As I told you before, even though we are making a three-dimensional game, it's going to have a two-dimensional spirit. Okay, it's going to look interesting. So we have to change our camera a little bit. Okay, right now, if you go and select the camera, you're going to see it's looking like this. You can see some rays getting out of it because it's in a projection perspective. It's going to more or less mimic how we see things, okay, the human eye. It has more or less the field of view of a human eye, okay, so we're going to have that look, okay, that three-dimensional look. But there's another way to see things, to render things. If you select the main camera and you look here, you're going to see that there's a projection mode. And there are two options, perspective and orthographic. If you change to orthographic, and I want you to pay close attention to the camera preview, it's going to look a lot different. Okay, the first thing that we see is the floor apparently disappeared, okay, which is weird. But if you look at the scene window, you're going to see how different it is. Okay, pay attention to these green lines. If you were in perspective mode, it looks like this. Okay, everything converges to the camera. But if you look at orthographic mode, you're going to have a rectangle. Okay, and this is pretty much how we do isometric gains. Okay, every pixel that we see in this square is going to be directly rendered in the camera. Okay, so we have not a very good sense of depth. There's actually no sense of depth. And one thing that's interesting is if you move the camera up or down, okay, and let's do it like this. I'm going to the game window. I'm going to change the Y value. Okay, we still can't see the floor, and we can't still see our player from the bottom or to the top. Okay, because there is no perspective here. We're simply tracing parallel rays from where the camera is and rendering everything we get. So in order to see things, we have to change the rotation. Okay, so as you can see, if I change the rotation like this in the x-axis, we start to see the floor and start to see other sides of the player. Okay, so if we change rotation on X to 30, like this, okay, we can now move up a little bit and we might be able to see more things here. If you go to the scene window, this is how it's looking like. Okay, so even if I change things in the z-axis, apparently we can't see much more here, so that's not going to make much difference. But if you want to increase the range of this camera, you can change the size of it here. Right now it's 5, so if you set to 10, it's going to increase the size that it's used for rendering things. Okay, so it's 5, I'm going to increase, and you see that the rectangle increases and we see more things in the camera preview. Okay, if we set it to 10, it's going to look like this. Okay, we can see the player from that distance. That might have been too much, so maybe 8 is going to be better. Okay, and now if we press play, we should be able to move the player like this, okay, to different places and avoid the enemies that are going to appear. But now, as you can see, it seems like it's not enough room for us to move our mouse. That reinforces that you have to update your game as you make it. Okay, so right now, one variable might be good for the player, but as you develop, as you change the camera, things might not be as good as before. So I'm going to change the speed for the player to 12. Okay, and another important thing, you have to define sooner or later what is going to be the way the game is going to be rendered. Right now it's in landscape mode, so the width is greater than the height, so you have to play with your device tilted. But for this game, it's interesting to play in portrait mode. So if you go to the game window and you click here, you're going to see that you have a few options. Okay, you have 5x4, 4x3, 3x2, but none of those options are portrait mode. They're all landscape. If you want to add more options, you can click on this plus sign, and you can go to type here and type aspect ratio, and let's type 3 for width and 4 for height. If we press OK, now the game window looks like this. Okay, it cropped a little bit, and we see the game like it's a vertical window. Okay, that's how we see the game now. And if you want to see how it's going to look in a widescreen device, you can just click here and select 9:16. It's going to look like this. Okay, and this is going to be very important for us to define what are going to be the limits for this game. Okay, keep in mind. The smallest value for the aspect ratio is 3x4 for mobile devices, and the highest is 9:16. We need to make sure that the game is going to work fine on both values, on both aspect ratios. So keep that in mind. Okay, and now that we have this, let's give this a try. We're going to press play, Let's see if the speed is good. Okay, so yes, 12 seems good to me. We still have this smoothness here, and after that we should be able to move on to the next lesson. Now that we have a player that can move, we should add a little challenge to this game. So we should start by adding the jumping enemies. Let's make a very simple one. I'm going to right click in the hierarchy window, choose create empty. I'm going to rename this game object as jumping enemy, and I'm going to change its position to be 0, then maybe 8, or might be too much, 6, and 0. Okay, let's make sure they are aligned in the z-axis. Okay, so we have the jumping enemy here, and now I'm going to right click, choose 3D object, and this time I'm going to choose sphere. Okay, so it's going to be a very simple sphere like this one. Now we're going to the materials folder, and we want to make a material for that so we can color that enemy. So right click, create material, and then jumping enemy. We're going to change this color to a nice tone of red, okay, maybe a little wineish like this one. Then I'm going to drag and drop and apply to the jumping enemy. Okay, so this is going to look more or less menacing to the player, okay, like this. You might want to make it on a higher position like 8, for example. Okay, and inside the jumping enemy, let's also add a model game object. So right click, create empty, rename as model, and drag the sphere inside that. Okay, so now that we have this jumping enemy, we need to change a few things. First of all, we're going to remove the sphere collider from them. Okay, so you click here and choose remove component. Right, so you have the jumping enemy here. But if we press play now, the enemy is just going to be hovering and it's not going to fall in the player. So we need to add two things. We need to click add component and add a rigid body. Okay, very simple. And we also have to click on add component and add a sphere collider. If you look at the scene window and you look closer at the jumping enemy, you're going to see that the sphere collider is taking the exact shape of the sphere inside it. Okay, you can tell that by these circles that are enclosing the entire model. Okay, but remember, this is in the jumping enemy and not in the sphere itself. Just as we did with the player, this is going to save us a lot of time later. Okay, so let's keep that in mind. Now, if we press play, the jumping enemy should fall in the player, and well, we can even hit it like this, okay, to make it move. But what we want to do is, if the jumping enemy touches the floor, we want to make it jump. Okay, actually, if it collides with anything, we want to make it jump. So what we're going to do is scripts folder, right click, create C# script, and this is going to be jumping enemy. Okay, let's hit enter, wait for the compilation to be finished, and once that's done, we need to attach the script to the jumping enemy game object. So we do it like this, or we can even drop the jumping enemy game object. Okay, let's also move it up so it's going to be a little bit more organized. So I click on the cog, move up, and the jumping enemy is going to be here. Okay, so how do we tell if this jumping enemy just touched anything, it collided with anything? You need to pay close attention to this. If you look at the sphere collider, its trigger is marked as false. If it was true, then we would only be able to tell if we were overlapping elements. But that's not the case. We still want physics to be applied. So we have to leave this disabled so we process collisions. So to check for collisions, we're going to open the script here in the jumping enemy, and we're going to make a new method that is going to be void on collision enter. It means if this method is called, we just entered a physical collision. And as a parameter, we have to pass collision. This is the class, okay, this is the type, and the name of the variable for this parameter is going to be collision. It can still look like that. And we can print the name of the thing we collided with. So you can type debug.log, then collision, then .transform.name. Okay, so just to test. It's important for you to, every time you do something new, if you're not very used, you can just print something to see if the collision is working properly. So if we press play and the sphere touches the player, we print this message, player. And if we get the player outside of it, then it's going to print cube, which is our floor. Okay, so we're able to tell if we're colliding. And by the way, let's get this cube and rename it to floor. Okay, so it's consistent. Now let's save the scene and let's move back to the enemy to perform the jumping logic. we need to define a variable that is going to be used for the jumping force. Okay, so here in the jumping enemy, we are going to type public float jumping force. And let's set 5F as a default. We're just going to test this out. Okay, so let's save this. And whenever we enter a collision, we want to apply a force in the vertical axis. So we're going to make it jump up. How do we do this? Here, we're going to type this. Get component of type rigid body. Okay, so get component is a method call, and we have to specify a type. So we type the lesser than character with the greater than character and rigid body inside it. We open and close parentheses, then dot add force. And we need to pass 3 parameters here, x, y, and z. So we're going to pass 0 on x, jumping force on y, and 0 on z. Now, if we save this and we go to Unity, we wait for the compilation to be finished, and if we press play, the jumping enemy is going to fall, okay? And as you see, it's colliding with things, but it's still not applying the jumping force because it might be too little right now. So let's try that again. Let's try using 100 for jumping force. Let's press play, wait for it to fall, and if it falls, as you can see, it's now jumping a little bit higher because we're using 100. So we can use, while the game is running, we can change the jumping force until we find a value that is going to look interesting. Okay, so 200 is too little. 500 might look interesting, but I think there should be more room for the player. So if you use 700, it's going to look like this. Maybe that's too much. So 6. Okay, we are experimenting here until we find a nice value. Okay, so it's looking like this. We should move here, and well, we can avoid the enemy. So we know that 600 as jumping force looks interesting. Let's stop the scene, go back to jumping enemy, set 600, save our scene, go to file and hit save scene, and we should be able to completely finish this. Okay, if it touches anything, it's going to look like this. Right? Now that we did this, we need to do a little interesting logic here. We want to make this enemy to move from the left to the right as well. Okay, once the enemy is almost up, we want to set a position for it to move to. Okay, a random position in the horizontal axis. Let's work on this in the next lesson. To make the jumping enemy to move horizontally, we need to define a range where the jumping enemy may move to. So here we're going to type public float horizontal range. Let's set that as 5 for now. If we save this and go to Unity, we should be able to define, by looking at the game window, what is the maximum range for that enemy. So we're going here, and we're going to move the aspect ratio to 9:16, and we're going to move the jumping enemy to the Y position 0. So it's here, and change the X until it reaches the limits of the screen. So that's going to be -4 here in the left and 4 in the right. Okay, so you can move back to 080, and in the jumping enemy we're going to set the horizontal range to 4. Actually, it's horizontal rage. That's not the case, it's not that angry. So horizontal range, let's also set 4F here. Save that, go to Unity. Then it's going to change here to have a proper name. There we go. And it's going to be 4. Okay. And what we want to do here is we want to get the exact moment where the velocity of the enemy switches from a positive value, so when it's moving up, and then goes to a negative value, so it's going to move down. Okay. So what we're going to do here is we're going to make a variable that is going to be private bool moving down. Okay. And in the beginning, we're going to set moving down to be true, okay, as it's simply going to fall. And in the update method, we're going to type, actually, when we do this jumping force here, when we apply the jumping, we're going to set moving down to be false, okay, because it's moving up. And in the update method, what we're going to do is, if moving down equals to false, so that means it's moving up, we need to check if the velocity is now negative. So we're going to type if get component of type rigid body dot velocity dot y is lesser than 0f, that means we are now moving down. So that is the exact moment where the velocity of the jumping enemy has changed. So we set moving down to be true, and now we need to set a target horizontal position. So here, private float target horizontal position, And here in the update we set target horizontal position equals 2. How do we make a random number? It's very simple in Unity. We can type random.range, which receives two parameters, the minimum value and the maximum one. The minimum value is going to be minus horizontal range, and the maximum is going to be positive horizontal range. No need for a sign here. We just type it like this. Okay, and now that we have the target horizontal position, we should make the jumping enemy to move to that position. We do the linear interpolation. So we're going to type transform.position equals to a new vector 3. Okay, actually we should type vector3.lerp. So first of all, the original position, which is transform.position. Second of all, we need to define the target position, and we should define a variable here to make this simpler. So vector3 target position is going to be a new vector 3. We want x to be the target horizontal position. Y is going to be whatever position we are right now. We don't want to change that. So transform.position.y. And finally, transform.position.z. Okay? So we don't change y or z, just the horizontal position. Now, finally, let's continue. Transform.position is a lerp that starts from target position, it ends in target position, and now we need to define the time component, so time.delta time. And we can also multiply that by speed. Okay, so let's change this here as well. We're going to add a public float speed, and let's use 3f, for example. Okay, now we save that. Let's make a few comments here. Get the exact moment where the jumping enemy moves down, and here moves the jumping enemy horizontally. Let's put move. Okay, move the jumping enemy horizontally. Let's give this a try. We're going to save that, go to Unity. Let's wait for the compilation to be finished, and after this is done, we're going to press play. Okay, so it's going to look like this. Okay, and you see now if it reaches the moment where it changes, it swaps positions. Okay, you can do this differently. You might want to use different logics if you want. Okay, maybe you want to change the position as it's moving up so it has a smoother experience, but this works just fine. And quite honestly, I like the surprise of knowing that the enemy is going to move to my position. Okay, it's going to work just fine. Okay, just leave it like this and it's going to be okay. And one thing that you might want to care about is we just want the jumping enemy to move in the X and the Y axis, not on the Z one. When we need to care about this if we have any other collisions here. So let's select the jumping enemy, and we're going to freeze the position on Z, and we can also freeze the rotation as well. Okay, this is not going to be necessary. So this is it. We have a working jumping enemy. Now, one thing that we have to do here is when the enemy touches the player, then the player should be destroyed. Okay, the player should die and it should be game over. Okay, so what we're going to do is let's open mono and we're going to the jumping enemy. Here we simply check if we collided with anything. Okay, we check the moving down logic, then we apply the jumping force, but we should also check if we have collided with the player. So we're going to type here if collision.transform dot, and now we need to check if it's a player. We need to check with that. We can check that with several different ways. We can check for the name of what we're colliding with, but that's not very safe because we might want to rename the player. We might check for the tag. That's something we have in Unity, but well, there are better ways. Or we could check if there is a component there, if a component exists. So we want to check if that object we collided with contains the player component, because if it does, it can only be the player we collided with. So now we type get component of type player, we open and close parentheses, and we check if that is different than null. Okay, so that means it exists. If there was no player component, this would return null. If there is, it would be the player component. That's different than null. So if this happens, we're going to call a method in the player that is going to kill it. So we're going to copy this line, paste it here, and we're going to type dot kill, and we open and close parentheses. Okay, it's going to be red now because there is no kill method, but we're going to save this, go to the player, and we're going to make a kill method. So here we type public void kill like this, and for now we're going to simply destroy the player. So I'm going to type destroy and type game object as a parameter. So the object of the player is going to be vanished from this game. Okay, so we wait a little bit more. Now we press play. So we have our player here, the enemy is going to be bouncing, and if it touches us, the player completely vanished from the game. Okay, that's going to be enough for now. Now we have a challenge, and we have to avoid that jumping enemy. Now that the player is able to lose the game, we should give the opportunity for the player. Actually, we must give the ability to the player to win the game. And in this case, we simply want the player to survive for as long as they can. Okay, right now we have one jumping sphere. We should wait for maybe 15 seconds right now for the jumping enemy to be jumping around. And if we beat that time, then well, we beat the game. And to do this, we need to make an user interface. We need a graphical user interface to show information to the player so they know where they're currently at. To make an interface in Unity is very simple. We right-click in hierarchy, we're going to choose UI, and then Canvas. Okay, there was nothing new added here, but if you look at the scene window and you double-click the canvas, you're going to see this. Okay, you might even want to press 2D to see that. So if this is your first time working with canvases in Unity, it's actually a pretty simple concept. Right now, it's like we have two cameras. We have the main camera that renders the game for us. So it shows the player, it shows the enemies and other things. And we have another camera that is going to render whatever we put in the canvas. And the trick here is, it doesn't matter what we add to the canvas, it's going to be rendered on top of the game. So for instance, if we select this canvas here, we right click on it, choose UI, and then we choose text. Okay, then we're going to have this new text message here, and if you look at the game, the text is going to be there, okay, on top of everything. If you move the player on top of that text, it's going to look like this. Okay, then, well, the text is going to be rendered on top of us. So what I'm going to do here is, notice that in the project window I've added a fonts folder, but you don't necessarily need this. There is a built-in Arial font that works just fine, but I've added another one here because it's going to be prettier. So in the fonts folder I have these ones: Oswald Bold, Light, and Regular. You can download these for free at the internet, or you can use whatever font you want. So to change the font, I can just select the text here, and I can change the font here from Arial. I'm going to click on this circle, and I'm going to choose Oswald Bold. Okay, that's going to be much easier for us to read. So this is what we have right now. And there are a few things we have to worry about. Notice that if I maximize this window, the text is going to be very small. Okay, and if the resolution is different, then the text is going to be big. So there is a bit of an inconsistency of what size is going to be used here. So to solve this, we need to select the canvas, and we need to pay attention to the canvas scaler. We need to change the scale mode from constant pixel size to scale with screen size. And we need to set a reference resolution. So what we're doing here is we're going to define a resolution that is going to be used throughout different devices. So for instance, if we can set X to be, for example, 1080 and Y to be 1920. Okay, so that's full HD resolution. So that's what's going to be used. And right now it's going to match the width, okay, of the screen. Let's understand this by practice. We're going now to select the text that we have. It's very, very small right now because we're using full HD. We're going to increase its size like this, and we're going to also increase its font size so we can read it. Right now it's 120. Okay, if you look at the game, it's looking like this. If we maximize, it's going to keep its size, but we also have to pay attention to the aspect ratio of the screen. Okay, we see that the size is consistent, but if we change the aspect ratio from 9:16 to 3:4, notice that the text scaled up a little bit more. Okay, initially it looks like this, and now it's looking like this. So the last thing that we have to do in the canvas is look here. Okay, we set scale with screen size, we set the reference resolution to be this one, and the screen match mode is match width or height. That's fine, but here it's set to match the width, but we want to match the height. Okay, because that's going to be consistent in different platforms. As your game is going to run only on the portrait mode on portrait devices, then we should match height completely. So we put 1 here. So the text looks like this in 3x4. It looks like this as well in 9x6. Okay, doesn't matter if it's maximized or not, the text size is consistent. That's very important. Okay, make consistent things so it's going to be more or less the same experience in all devices. Okay, now we're going to grab this text and we want to move it up. Okay, we want this text to be, let's select the transform tool and we're going to move it here. Now, another trick for you. If you look at the game window right now, the text is in this position. But if you change the aspect ratio to 3x4, the text is still going to be in the same place. But that's a bit odd. Okay, we want the text to be anchored in this top left position. Okay, so it's going to follow the size of the screen, whatever it is. To do this, we can simply select the text. And here we have some sort of anchoring mode. I'm going to click here and I'm going to choose this one, top left. Okay, and if you look at the scene window, you're going to see the changes in this. Okay, it's much better to leave it here instead of the game window. Okay, let me move closer here. So it was like that before. Okay, it was centered here. You can see the anchor here. But if I move to this position, it's going to be here. Okay, and one thing that you might want to do to improve the positioning logic here is you want to change the pivot. So X I'm going to change to 0, so the pivot's going to be in the left, and Y I'm going to change 1, so it's going to be on the top. So this is now considered the origin for this text. Now I'm going to set the position on X to be 20 and Y to be -20, so it's going to look like this. Now that we have this, we can go to the game window. Okay, new text is here. We can change that to 3x4. It's going to be anchored here. 9x16. It's going to be here. Okay, so that's properly anchored. And now what we want to do is to transform this text into an informational text. It's going to tell how many time is left. So in the text here, we're going to type time, a colon, 0s. It's going to be 0 seconds. And what we have to do is we need to make a logic for making a game timer, and we're going to tell if the player won the game. Okay, so let's save the scene and move on to the next lesson. We now have to make something that is going to control the rules of the game and also update the interface. So we're going to make a game controller. I'm going to right click here, choose create empty, and this is going to be a game controller. Okay, I'm going to move this to this position in the interface, and we're also going to make sure that the position of it is going to be 0, 0, 0. So the game controller is going to be here. Okay, it's an empty object. And now we're going to select everything else that we have except the canvas and the event system and drag inside the game controller because they all belong to the game. Okay, just to keep things organized. Now we're going to save this. And now we need to make a script for this game controller, and we need to name this game mode. Okay, it could be something like avoider or jumper. It could be different ways. So let's right click here, choose create and C# script, and let's name this avoider game controller and hit enter. Okay, so after that we select the game controller that we made here, and we're going to apply this script here, avoider game controller. Alright, so to begin we need to set the time for the game, the duration of the game. So I'm going to type here public float and then duration. Let's set 15F as default. And now that we have the duration, we also need to have a timer. So I'm going to type private float timer. Okay, and in the start method I'm going to set timer to be the same thing as duration. Okay, this is going to be our internal clock for how long the game is going to be running. In the update method, we're going to type timer minus equals time.delta time. Okay, this delta time property here is going to return how many seconds have passed since the last frame. Since we are in the update method and the update method is called once per frame, this essentially is going to work as a countdown timer. Okay, if 1 second passes, then timer is going to be 1 unit lesser than what it was before. And we need to check if timer is lesser or equal than 0f. That means that the player won the game. Okay, so let's do things one by one. First of all, in the update method, we want to set the text that we have. Okay, so we need to have a reference to that text. So let's make a few adjustments here. We're going to type using UnityEngine.ui in the beginning of the code. This is going to add the user interface namespace for us, so we're able to deal with text, with images, with sliders, with layout adjusters, several different things. Okay, and here we're going to type public text info text, right? And you notice that we have kind of two categories of variables here, and if we don't worry about organizing this soon, it might turn messy. So what I'm going to do is I'm going to add an attribute here. We're going to add two brackets, then header. We open and close parentheses, and between parentheses I'm going to type gameplay. This is not going to change how the code works at all, but it's going to be cleaner in Unity. And here I'm going to type header and UI between double quotes. Okay, so it's going to look like this, and I'm going to save this. Now, if you go to Unity and you look at the game controller, at the variables that are going to appear, we have a label called gameplay at the duration and a label called UI, and then the info text. This makes a huge difference in the end game here. Okay, if you're working on a big project, it's going to make much easier to find things, and it's actually going to help you on developing a cleaner code. Now we need to make a reference for the info text because right now it says none. So I'm going to open the canvas, bring the text from here and drop it here. Okay, now we can access that info text. And now we should move forward with improving the logic here. In the update method, we're going to type here, if timer is greater than 0f, okay, let's do it like this, else we're going to do something else. So if timer is greater than 0, then we're going to type info text.text equals 2. Then we need to make a string. It's going to be time, colon, and space. We finish the string plus timer. Okay, so let's see how this is going to look. We're going to save that, move to Unity, wait for the compilation to be complete, and we're going to press play. Okay, so here we are, and you see the timer is very, very difficult to read because we have that huge decimal part here. So what we can do is instead of simply typing timer, we can type mathf.floor, okay, or we could type ceil, but let's use floor for this. Okay, it's going to convert that number and it's going to remove the decimal part. Okay, it's going to be much easier to read. If we save this and go to Unity now and wait for that to be finished, we're going to press play. And we're going to see that the timer is going to decrease like that. It's going to be much easier for us to read. You could see that it started at 14, okay, because the time starts at 15, but at the first frame it's going to be smaller than 15, and since we use floor, we won't be able to see 15. So that's the moment where you have to decide between using floor and ceil, okay, but well, I think this is going to work just fine for us. So what if timer has reached 0? That means the player won the game, okay, if the player didn't die. So here we need to check if the player died. So we need a reference to the player. We're going to type public player player, okay, and here in the else we're going to type if player is different than null, it means that the player is alive. Okay, so we're going to type info text.text equals to you win. Okay, so we're going to save this. Let's go to Unity, wait for the compilation to be finished, and after that is done, we're going to drag the player from here to here. Okay, so it's properly assigned. All right, and now that we have done this, we also have to check if the player died. Okay, so we're going to check if player equals, if player equals to null, that means that the player died. So let's type here, check if the player is alive or is dead. So if the player equals to null, that means the game should be over and the player lost the game. So we can improve this a little bit. We can type here private bool game over, that is going to start as false, and private bool win. Okay, so if player equals to null, we're going to type game over equals to true and win equals to false. Okay, game over because the game finished, and win is going to be false because the player died. And here we're going to check else, so if timer is lesser than 0, so we check if player is different than null, that means game over equals to true and win equals to true as well. Okay, so here we're going to check if the game is finished. Okay, and now for the third block we're going to type send the game over message. So we're going to type if game over equals to true, then we're going to check if win equals to true, or we can just type if win. Both ways work. We're going to type infotext.text equals to you win. Else, so if the player died, we're going to type infotext.text equals to you lose. Okay, so we just tidy things up a little bit. We have a game over variable, a win variable, and if the player is dead, game over is going to be set to true and win false. If the time has finished and the player is still alive, then we do this. Okay, so we're going to save this. Let's go to Unity. We wait for the compilation to be finished, and after that's done, we're going to press the play button. Okay, so the player is here, and I just touched the enemy and I died. Okay, so we see the you lose message. Let's try to avoid that. So it's going to look fine for now. If we survive for 15 seconds, we should be able to see the you win message. There's going to be one more adjustment that we have to do. Okay, so 3, 2, 1, so that times 0 and you win. However, the sphere can still hit the player and say that we lost the game. That's a bit unfair. Okay, so what we're going to do here is, if we win the game, we need to set the player to be invincible. Okay, so here where we set win equals true, we're going to type player dot, then we can type set invincibility. Okay, or we can type this player dot invincible equals to true. And now in the player, we're going to do two things. We're going to make a private variable that is going to be private bool invincible. It starts as false, and we're going to make a property so we can set that invincible variable. Or we could also make things simple and make a public variable, but this is going to be more tidy. Okay, it's going to be tidier. So public bool invincible. Here we're going to type set, and we're going to type invincible equals to value. So if we save this and we type here player.invincible equals to true, true is going to be passed as a parameter here in set with the name value, and it's going to be set in invincible. And now in the player where we have kill, we're going to type if invincible, then we're going to return. We're going to stop the execution of this method here in this return call. Even though it's a void method, it still works. Okay, we stop the execution, it's going to be okay. Now we're going to save that, go to Unity, wait for the compilation to be finished, and after that's done, we can press play. Okay, we're going to avoid that enemy, it's going to be jumping around us. So let's wait for the game to be finished, and we're going to see if the player is really invincible. Okay, so we beat the game. 2, 1, 0, and you win, and if it touches the player, nothing special happens because we're invincible now. Okay, so that's great, we have a fully working game.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.